Okay, so this is the rest of the notes from yesterday. It's on the back. So first of all, what is the parent function here? 3 to the x. That's my parent function. So everybody's writing down the parent function. Boys, no. So I write down the parent function. The next thing I'm going to write down is what are the transformations. So the -1 is 1 to which way? Right? And the -4 is 4 down. Now, I'm going to do the exact same points every time. So I'm always going to start with 0, 1. So if 0, 1 is my point, I'm going to move it 1 to the right and 4 down. The second point I get from the parent function, which is why we write this down. So if I put a 1 here, my second point is 1, 3. So I'm going to go over 1 and up 3, and then I'm going to go over 1 and down 4. 1, 2, 3, 4. Where's the asymptote? It's at 0. The only thing that affects the asymptote is the up and down movement. So do I have an up and down? So I'm going to move my asymptote down 4. 1, 2, 3, 4. And connect the dots. Number 2. Yeah, we're not on your homework you're going to have to, but we're not going to hear. What's the parent function? 1/2 x. So next, what are the transformations? The negative means reflect over x, and the +2 is 2 up. Which point do I always start with? 0, 1. If I reflect it over the x, that's down here, and if I go up 2, 1, 2, I'm right back where I started. My second point, if I put a 1 in here, do I want the 1? What do I want? 2's not going to help either. -1, because -1 flips the fraction. So -1, so my point is 2. So when I reflect it over the x-axis, and then up 2, I end up right here. So next, my asymptote was at y = 0. But I have to move it up 2. So here's the asymptote. And here is my graph. So what is the parent function for number 11? It's what? Alyssa. To the x. So, what is the 3? Vertical, vertical. And then the +5 moves it 5 which way? 5 to the left. Okay, so if I start with 0, 1, I have a vertical stretch of 3. So vertical is times y. So 0, 1, if I multiply the 1 times 3, I'm at 0, 3. And then I move 5. 1, 2, 3, 4, 5. So where do I want my next point to come from? -1 and 1, 2, 3, 4. So then from there, what do I do? Before I do that, multiply by 3. And here's where you all freak out, because what happens? Oh gosh, so we just can't do that? Heck yeah, right there. And then over 5. 1, 2, 3, 4, 5. So the next thing, Are either one of these an up-down shift? So where does the asymptote stay? Stays right here. Connect the dots. All right, everybody try the next one on your own. Try. So my parent function is e to the x. I have two transformations. What are the two transformations I have? Reflect over the y. And then 3 up. So here's my first point, 0, 1. So if I reflect over the y, does that move? No. And then 3 up. 1, 2, 3. So what's my next point? What did we say E was about? Okay, so 1 and 2.7. So I'm right there. So if I reflect it over the y, what happens to that point? Okay, so it's over here. And then what? So 1, 2, 3. So do I have an up and down now? Yeah, so where does my y asymptote go? Up 3 and connect the dots. Bam. Okay, so next, what's one of the transformations I have here? What's the 2? It's horizontal, right? Okay, so everybody listen. Put your pencils down and put your eyes up here and listen for a moment. Okay, so we all understand vertical stretch. If I'm holding a balloon, and I stretch it, what happens to it? Longer and thinner, right? It gets longer and thinner. Because which variable am I multiplying? The y. So the y is getting taller. Does that make sense? That's why it's a stretch. So then if I multiply it by 1/2, that's like me pushing on the balloon. I'm cutting it in half. What happens when you push on the balloon? It gets shorter and wider, right? So that's why it's a vertical compression. All right? Now, when I shift, and I'm going to do horizontal. So I'm still holding the balloon. If I do a horizontal stretch, if I pull horizontally, what happens to the balloon? And like I'm pulling, so what's happening to the balloon? Shorter and fatter, right? So that's why this changes. If I've got the balloon and I'm pushing on it, if I compress it, if I push it together, what happens to the balloon when I push on it? It gets taller and skinnier. Okay? So it's almost the same thing as the vertical. You're just doing the opposite with the y, the x's. Does this make sense? Because some of you, I think you can't imagine why this is happening. Like you can't envision it still. And that's why you're having a hard time. So this time, the number is 2. 2 is greater than 1. 2 means I'm pulling it. So what's happening to the actual function if I pull on it? It's going to get, right? It's going to get shorter and fatter. Does that make sense? Somebody just shake their head, yes, make me feel better. Okay, so if I have 1/3 as my parent function, the negative is a reflection over the x. The 2 is greater than 1, so it's a horizontal compression of 1/2. Because 2 is pulling, it's getting shorter and fatter. And then the -1 is 1 to the right. So first of all, can we predict, does the asymptote move? It doesn't, because there's no up and downs. The next, I'm doing 0, 1. Reflection over the x. That goes here. Horizontal compression. That means I'm multiplying times x. But my x is what? 0. So nothing. So I'm going to move it this way 1. So where's my next point? Do I want positive 1 or negative 1? Negative 1, because that flips the fraction. So I get negative 1, 3. So I'm going to reflect over the x-axis. So here. Now, I get a horizontal compression of a half. Well, what's my x right now? If I multiply by half, where does that go? Right here. And then what do? Go over 1. So here's my point right here. So connect the dots. Kapow. What's my parent function? So the 1/3. Right. It's less than 1, so it's a horizontal stretch of 3. And then I can't see, is that a +2 or -2? +2. So we're going to go 2 to the left and 1 down. And this is times the x, right? So my very first point that I start with every single time, no matter what, is 0, 1. So horizontal stretch multiplies to 0 times 3, which is still 0. So I'm going to move 2 and down 1. What's my first point, friends? I'm going to go over 1 and up what? 2.7. So it's about right here. So my horizontal stretch of 3. So I'm at 1. So 1 times 3 is, so I go over to here. And then what do? Go back 2, which is where I started, and down 1. And out of all of the transformations, what's the up and down movement? What did I move? So that's where your asymptote goes. And connect the dots. So now you can finish the worksheet I gave you yesterday. And that'll be due on Tuesday.